Very good morning. Welcome to YouTube channel. In last class, that is lesson 5, we have discussed about splitting field and degree of extension. Now in this class, we are going to see prime ideal and maximal ideal and then problems. First we know the definition, the well-known definition. An ideal, the n is the ideal, which is not equal to r, that is a ring, it's a commutative ring, is a prime ideal if AB belongs to n, that is A into B, then belongs to n, which implies either A belongs to n or B belongs to n. For A comma B belongs to R, the ring. So this is a classical definition of ideal. The note is very important, that is singleton 0. See, a prime ideal in Z. It's important one. The next definition, maximal ideal. So what is a maximal ideal? So a maximal ideal of a ring R is an ideal M different from R, such that there is no proper ideal N of R properly containing M. So now we have seen the definitions. Even though we have seen the definitions, for best we take problems, then you can understand very easily, I think so. So next, problem solved in prime ideal and maximal ideal. The first problem, find all primal ideals. Find all prime ideals and all maximal ideals of Z6. Integer modulo 6. That is the order of Z6, we know very well, is 6. So what about the divisors of 6? We know very well. 1 is a divisor of this, 2 and 3 and 6 are there. So there are 4 divisors. That is Lagrange's theorem. So Z6 having the elements, we know very well, 0, 1, 2, 3, 4, 5. So ideal 1 first, that is I am going to take 6 by 6 where 1 singleton element, that is 0. Just now you have seen 0, singleton 0 is a prime ideal, we know very well. Next, I2 6 by 3, this one 6 by 3, 2 elements. So what are the 2 elements? 0, 3. Next ideal. Next, I3 6 by 2, so 3. So 3 elements. One is 0, 2, 4. The last one 6 by 1, 6. So 6 elements. 0, 1, 2, 3, 4, 5. So it is nothing but Z6. Am I right? So among these 4 ideals, which one is the prime ideals and maximal ideals? Am I right? The easy tricky method 6 we can factor the prime factor 2 into 3. So 2 elements among the 4 ideals is 0, 3 and 3 elements among the 4 ideals. So just now we have seen 0 to 4. So 0, 3 and 0 to 4 having 2 elements, 3 elements. That is the prime. 2 is the prime, 3 is the prime. The number of elements 2 is the prime, number of the elements 3 is the prime. So that these are all the prime ideals of Z6. So very easy, right? Next, we know very well I1, that is a singleton 0 contained in I2. Alright, 0 is contained this, otherwise I2 contains I1. Then I2 is contained in I4, right? I4 is nothing but Z6. Now next, I3 is contained in I4. I3 is contained in I4. Otherwise, I4 contains I3. So I4 is nothing but Z6. So what we have to find out, that is a maximal ideal. Just now we have seen the definition of the maximal ideal. So we have to find out the maximal ideal of Z6. Am I right? So well known, this is the maximal ideal. Am I right? Because we have to find out this maximal ideal of this one. So I3. Next one, maximal ideal of this one is I2. So I2, I3 are maximal ideals of Z6. So 0, 3, 0, 2, 4. Both are prime ideals and maximal ideals. We know very well one theorem. Every maximal ideal in a commutative ring R with unity is a prime ideal. Am I right? Here the maximal ideal 0, 3, 0 to 4. So immediately you can say these are all the prime ideals. Am I right? So using this result, first we have to find out maximal ideals. Immediately we get prime ideals. So very important one. Please note this. The next second problem, very interesting one. Which of the following are maximal ideal in Z? The 4 options are given: 2Z, 4Z, 3Z, 5Z. Before entering this question, we have seen an interesting result. That is PZ is a maximal ideal in Z, where P is prime. These results are very useful for this problem, right? So PZ, we know very well 2 is the prime, then 3 is the prime, 5 is the prime. So 2Z, 3Z, 5Z, well known, they are all the maximal ideals. So clearly which option is correct? A, C, D. So third option is right. Alright, A, C, D. So clearly or a maximal ideal in Z. So using this result, immediately we choose the correct options. So in competitive examination, using the important results, using this result, our time consuming. Immediately we can, no need to write the all the ideals then find out the maximal ideals. It's a lengthy process. So using this simple result, immediately we get the correct options. So remaining options are wrong. Similarly here also, just now we have seen every maximal ideal in a commutative ring or with unity is a prime ideal. So before finding the prime ideal, the first finding the maximal ideal. So immediately we can find a prime ideal using this result. So in exam point of view, time is very important in competitive examination. Next, third problem we are going to see, a very interesting problem. Which one is maximal ideal in 2Z? So what is the difference between second problem and third problem? See here, which are the following are maximal ideal in Z? Here in Z. So in this third problem, which one is the maximal ideal in 2Z? The main difference. The four options are given. So what about the 2Z? We know very well what is the 2Z. 0 plus or minus 2 plus or minus 4 plus or minus 6 and so on. Well known this one. First I take this option 6Z. So what about the 6Z? 0 plus or minus 6 plus or minus 12 and so on. What about the Z? That is the integer set. 0 plus or minus 1 plus or minus 2 plus or minus 3 and so on. What about the third option? 3Z. 0 plus or minus 3 plus or minus 6 plus or minus 9. D option is 2Z. That is itself 0 plus or minus 2 plus or minus 4. So but we have to find out the maximal ideal in 2Z. So which is not possible because we are going to find out the maximal ideal of 2Z. So take this case, 6Z is contained in 2Z very clearly, alright. 6Z, the elements are in 2Z. Then 2Z elements are in Z. Am I right? But what we have to find out the maximal ideal of 2Z. Am I right? We don't want maximal ideal of Z. We need a maximal ideal of 2Z. So 6Z is a maximal ideal. Am I right? Moreover, 2Z, 3Z, 6Z, the elements are in Z. The question is, you have to find out maximal ideal of 2Z. So one and only 6Z. So remaining options are wrong. The question is maximal ideal of 2Z. That is very important. So that's why we choose this the correct option. 6Z is a maximal ideal in 2Z. I think easy to understand. Next problem. Please note this problem. Very exam point of view, this topic is very important. So from the third problem, we have one beautiful result. Every prime ideal need not be a maximal ideal. Just now we have seen every maximal ideal is prime ideal. For example, take this third problem. 6Z is not a prime ideal. well known. But it is a maximal ideal, am I right? 6z is not a prime ideal, but it is a maximal ideal. So every prime ideal need not be a maximal ideal, but every maximal ideal is prime ideal. Am I right? Again, we review that one here. That is after the first problem we have seen every maximal ideal in a commutative ring or with unity is a prime ideal. But every prime ideal need not be a maximal ideal. So very good example of the third problem shows that is this third one. It is not a prime ideal, but it is a maximal ideal. So next, fourth one. Find all prime ideals and all maximal ideals of Z2. Then class Z2. We know the Z2 element 0, 1. So these are all the well known. So how many elements? 4 elements. What are the divisors of 4? 1, 2, 4. So 4 by 4, 1 element, that is trivial. This one 0, 0. Next 4 by 2. Am I right? 2. That is this one over this 2 elements 0, 0, 0, another one ideal. Or next ideal 0, 0, 1, 0 is also. Then next 4 ideals only, I4. I4 is nothing but Z2 cross Z2. But we have to find out the maximal ideal of this one. So default, which is not a maximal ideal. So only possibility is maximal ideal is I2, I3 only. Right? We know the one tricky concept, that is 4 elements, prime factors only 2 into 2. 2 is a prime, right? 2 only prime. So 2 elements. So 2 elements ideals are only 2. That is 0, 0, 0, 1. Another one is 0, 0, 1, 0. These 2 ideals only having 2 elements. So these 2 should be maximal ideals. Am I right? So or prime and maximal ideals. Because this is the maximal ideals. Just now you have seen every maximal ideal is prime ideal. So both are prime and maximal ideals. The last fifth one problem, very interesting one. I take A as ideal to B. What about the A union B? Is ideal or is not ideal and may be ideal? 4 options are given. So we have discussed this problem. So 2, we know very well this one. 3, this also. What about the A union B? You can union these 2 elements, -6, -4, -3, -2, 0, 2, 3, 4, 6 and so on. The well known this steps. I take 3 element in A union B. Am I right? 3 I take. Then I take 2 1 element. But what about the 3 minus 2? 1. But 1 does not belongs to A union B. So according to the definition of ideal, A union B is not ideal. Am I right? Should be 1 belongs to A union B. But here 3 minus 2. 3, 2 are in A union B, but 3 minus 2, 1 does not belong to A union B. So definition of the ideal, this element should be in the A union B, but here does not belong to A union B. So A union B is not ideal, very clearly. So we know the result, that is the union of 2 maximal ideal is not maximal ideal, very important. union of ideal is not ideal. That is example of the fifth one. Am I right? Am I right? This is a very good example of union of ideal is not ideal. Union of ideal is not ideal, but intersection of two ideal is ideal. So thanks for watching video, and more to I have to thanks subscriber to support the upload the useful videos. So best prepare the books Gallian and Higher History, very useful books. We prepare notes individually, own notes prepare. We have to prepare own notes. Take a book, take the result and theorem, then go to the exercise problem. We have to try to solve the problems. Then we get idea very clearly. So thank you. Thanks a lot. Please, suppose you are satisfied after watching this video, share your friends. It's very useful. Not satisfied,